Assalamualaikum warahmatullahi ta'ala wabarakatuh. Today our group will demonstrate how the list data structure is implemented using pointers. My name is Nur Aisyah binti Norazman and my other group members are Sister Maryam, Sa'adah and Husnina. So I will start with the introduction to the pointer list. First of all, we need to know what is a list. A list is an abstract data type that represents a countable number of ordered values where the same values may occur more than once. So what about linked list? A linked list is a data structure. They are the ways to store data or elements that we want to keep track of. So in other words, it is a series of connected nodes that are connected together via links. In the linked list, there is a head that points to the first node. Each node contains at least a piece of data, any type of data, and a pointer to the next node in the list. The last node will point to the null value. Why use pointer list? We use pointer list to ensure that the list is not stored contiguously and use only as much space as needed for the elements currently on the list. It only requires space for the pointer in each cell. Next, what is the advantage of linked list? Linked list is dynamic, which means that we don't need to know how many nodes will be there in the list. It is also easier and faster to do insertions and deletions rather than using arrays. Linked lists give us a way to keep a list of data where we can insert and delete wherever we want without a lot of copying. So, we have three types of linked lists, which is simple linked list, where item navigation is forward only, then double linked list, the item can be navigated forward and backward, and lastly, circular linked list, where the last item contains a link of the first element as next and the first element has a link to the last element as previous. Alright, now we move on to how we want to list all the elements in a list. I have two ways to list an element in a list. First way is to assign the node ourselves and the second way is to take input from the user. So for this project, we use the method of assigning nodes ourselves to make it easier for all elements to do the coding. However, I also include coding that takes input from the user to provide a clearer explanation of this data structure. So now, let's look at the first coding, which is to assign nodes by ourselves. In this project, I use C++ to do the coding. So here, our linked list is going to be a class. To keep it simple, I'm going to store an integer number, which is data, in my class and also the next pointer to the next element or node in the list. Basically, everything inside this curly brace is going to be part of our class. Okay, so now I have a class that represents my nodes. So how I'm going to make it into a list? Well, let's make 3 nodes and set their values. Then we will link them up into the list. First, we will make the head point to the data of n1, which is 1. Then, we set the node to point to the address of the next node. Repeat this on each node until we want the list to stop. So, to make the list stop, we will set the next pointer of the last node to be null. Now, we have the list. Next, we will add a function that prints out the linked list if we pass in a head or n1 here. I add an arrow here to make it clearer. So, we basically pass the head pointer that tells us where to start. In our case here, the head is n1. So, as long as the value is not null, it means that the list has not hit the end yet. So, we will print out the value of each of the nodes until it hits the null value. If you don't want to be confused, you can change this n1 name here into head and add here temporary value to make it easy to know that we will print different node values. Now, let's try to execute this coding and see the result. You can see that all the numbers here are linked and the last number point to nothing or null here. We usually use linked list when we don't know how many lists we are gonna need and we want a list that will grow to whatever size the list need to be, and that usually does not mean a few statically allocated nodes like the first coding earlier. Instead, we usually dynamically allocate our nodes on the heap by using malloc. So this is why I will show you an example on how this is done. The second coding is made using C language. We will create a linked list with n number of nodes and display it. Here we use type-struct node. We use type-struct node because we want to rename this structure as node, and it is because we will not use this struct node all the time. So in the struct, there were also two data like C++ coding earlier, which is an integer number, which is data, and also the next pointer to the next element or node in the list. The difference here is we use C instead of C++, and we make a function to create linked list based on the number that user enter, where we allocate the memory based on user input. So that is why in the beginning, we need to ask the user how many nodes they want to create, and the data will be stored in the n variable that we declare here. Here we create an isolated node. You might think why there is an ampersand here when temp is already a pointer. It is because the ampersand is not for temp, but it is for temp arrow data, which means that it is for the data part on that node. So let's try to execute this and see the result. Here we need to input how many nodes we want and the data that we want to store. It will show how the data is linked to each other. This is the final outlook of the list. So that's all from me. I will pass to the next presenter. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Sa'adah binti Mohammad Nor. My matrix number is 1911510. So I will present about list using pointer. My part is find an element in a list. As example, we want to search 20 in a list that consists of 10, 20, 30 and point to the tail which is none. First, current, we know that current holds the head of the data which is 10. But current is not equal to the key which is 20. So we move to the next node. Because we move to the next node, so here current is 20. So 20 is equal to the key that we want to search. So we found the element in a list. So here is my code. First, I provide a function to search element in the linked list. First, I use boolean search element for the function name and node pointer to the n1 or head and integer y, which is the key that we want to search. Node pointer to the current equal to n1, meaning that we initialize current to the head of the data. And then y, current is not null, because if current null, it will give error. Then if current is point to the data is equal to the y, meaning that equal to the data that we want to search, then return true. And then current go to the next. Then if the data is not equal to the integer or y that you want to search, it will return false. Then in the main function, we will call the function which is search element, and we put the head which is n1, and then we put the any element that we want. As example, I want to search 2 in a list. And then this statement is to print the result. If the function return true, so it will print yes, search found. But if the function return false, then it will print no, search not found. So let's run the code. So let's run the code. So here, this is my function to search an element in list. And here, this is my function call in a main function. Let's say we want to search 2 in a list. The result print out yes, search found, meaning that 2 is present in a linked list. Let's try another example. Let's say we want to search 4 in a linked list. So 4. So the result is no, search not found, meaning that 4 does not include in this linked list. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Maryam binti Jumadin, and my matric number is 1810676, and I'm going to present about insertion of new elements in list. So basically, there is 3 ways of insertion, which is from the front, from the back, and in the middle. But for this project, we are only using the front and the back. So the first method is insertion of new element in list in the front. So if we are going to add a new element in the front, we need to push the original head of the element, which means at first the head of this list is the data 1, but after we insert 0 into this list, it will push the A and it will enter the space of the N1. And D data 0, node 0 will become the new head. So basically, this is the code. First, we need to allocate the node for the new data. And previously, the node is D, but later on, it will become A. And then, we enter the data, which is 0, our data. And then we declare next of the new node as the head of the list. So we will declare the 0 as head. And lastly, we move the head to point or refer to the new node. So N1 reference will refer the position, will put the new node. In the main, we are going to list front N1, which is our head, N1 is our head, and the data that we want to input, which is 0. We insert new 0, new node 0 in front of the existing list. So the list will become 0, 1, 2, 3. So we this is the new results, will become 0, 1, 2, 3. Previously is 1, 2, 3. So the next method is the insertion at the back, which means our head won't be, we won't touch our head, we just put it at the back. So D3, supposedly after D3 is null, but we will put E4, our new data for new node for before the null. It will change. After the 3 will become will have 4 and then null. This is our code to add a new node at the back of the list. First, we allocate the node for the new data, and then we set N1 or head the reference of the position as the last position, because we want to put the position to the last. And then we enter the, we need to enter in the data, which for our project we put 4 for this system. Then since we are making the new node as the last node, so there is supposed to be no other node after the new node. So after the new node will become null. And then we will automatically make the new node as the head if there is no list, the list is empty. But since our list have elements, it will make the node as the last node. And we will change the next of the last node, the next is to the new node. This is in the main. We put the back, which we call for this. And then N1 4 is the new node that we want to add. And then we will print it 0, 1, 2, 3, 4. Hence, our latest list will be 0, 1, 2, 3, 4. I'm going to pass to my friends to present about the deletion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Husnina binti Patohar, metric number 1817234. Next, I will present the deletion of existing element in a list. Delete node from the linked list has two ways. Either we delete in the beginning of the list or at the end of the list. For this project, I choose to use function delete at the beginning of the list. Here, I will explain how this function works. This is our list. The head point in the first node containing value 1. So for this, we use function node pointer equal to hit. Now the pointer PTR is pointing at the value 1. If we delete the first node, the second node will be the first node after deletion, and the head will point to the second node. So then we use second function head equal to head. Now the head had transferred to the second node. Lastly, we just use the function delete in bracket PTR. Now the first node are deleted from the memory. So next is the implementation using C++. This is the function that I use to delete at the beginning of the list. Void delete back for beginning. The function if head equal to null, cout list is empty, or else, like what I explained in the previous slide, else node PTR equal to head equal to head equal to next, and delete in bracket PTR. So the call function is delete back in bracket. That's all from us. Thank you.
Hence, this is our full code, and we're going to run it. This is our result. So there is a print list of the original list, which is 1 to 3, and then when I'm added 0 in front of the list, and the new list becomes 0, 1, 2, 3, and then when I add 4 at the back of the list, the new list becomes 0, 1, 2, 3, 4, and then we also have the system search. And first we try to search for element 2, and yes, there is element 2 and search found, and we try some element that is not in the list, such as 10, and the result will become no, search not found. And lastly, our deletion, we delete 0 is deleted from the front of the list. We use deletion from the beginning. Our new list become 1, 2, 3, 4. That's all from us. Thank you so much.